So we have an example here where they're giving us an equation, an exponential equation, y equals 1200 parentheses 1.3 to the t, and they're asking us a couple of questions about it. The first question says, does this function represent exponential growth or exponential decay? Now, if we go back to the two equations that we've used so far for growth and decay that I have over here, you notice that the only difference between an equation for exponential growth and an equation for exponential decay, the only thing that's different is whether we are adding the rate that is given to us or whether we are subtracting the rate that's given to us. Now everything else stays the same. You still have y equals, you still have your initial amount of a, and you still have your exponent with the time that interval that we're looking at. However, the difference, as I mentioned, is whether we're adding or subtracting. So that difference affects what's going to happen to the 1 that we have inside of the parentheses, right? If I have y equals a parentheses 1 plus r to the x, that means that the whole that I'm beginning with is going to be increased, is going to grow. So whatever I'm going to have inside of the parentheses, if it's a growth, is going to be bigger than 1, right? Everything else is going to remain the same, but if I'm adding a rate to the whole, to that 1 that I begin with, what's inside of the parentheses is going to be bigger than 1. That's for a growth. However, if I have y equals a parentheses 1 minus my rate, means I'm taking away from the whole. My whole is becoming smaller exponentially. It's decreasing or going down. That means that what's inside of the parentheses then, what's going to happen to that 1 is if I'm subtracting from it, it's going to give me something that is smaller than 1. And that's if I'm looking at something that's decaying or going down. So again, the growth or the decay is going to affect whatever's happening to your whole, which then will affect whatever you're going to have as a result inside of this parentheses. You're either going to have something that's bigger than 1 if it's growing, your whole is becoming bigger, or you're going to have something that's smaller than 1 if it's decaying, meaning your whole is becoming smaller. So using that information, let's see what we have here. Does this function represent exponential growth or exponential decay? Well, if I have y equals 1200 parentheses 1.3 to the t, and again I'm looking at what's inside of this parentheses, I'm looking at what happened to my whole, what happened to my 1. Well, right now I see that I ended with something that was bigger than 1. I had to add to that 1 in order to get from 1 to 2.3. So since my 1.3 is bigger than 1, that means then this is an exponential growth. Okay, because I started with 1, I started with my whole, I added something to it. I don't know what I added to it just yet. I added my rate to it, and I ended with something that is bigger than 1, because 1.3 is bigger than 1, which means this is an exponential growth. Now the question is, what is your initial value? Well, I know that my initial value is always the a. It's always the amount that's before what I have inside the parentheses. So if I have y equals 1200 1.3 to the t, then my initial value, it's whatever I have outside of my parentheses, which is that 1200. So my initial value here is just simply 1200. Now part C asks, what is the rate of growth or decay? What is the rate of growth or decay? Now the rate of growth or decay is also going to come from the parenthesis piece, right? Because it's the R, I'm either going to add it or I'm either going to subtract it from my whole, and then that's going to affect what I have left over inside of my parentheses. So if I have, again, y equals 1200, 1.3 to the t, I'm looking at this 1.3, and I already know it's a growth because I have something that's bigger than 1, as we mentioned in part A. So I'm trying to figure out what was the r, what did I do if I work backwards. If I work backwards, I had 1200 parentheses 1 plus my rate. I don't know what my rate is, but I'm trying to figure that out, to the t. So I'm trying to figure out what did I add to 1 in order to get to 0.3. And now some of you guys might be able to figure this out without any calculations, but just in case, I'm going to show you a simple way that you can do this. I'm trying to figure out how do I go from 1 to 1.3. So what I'm going to do is I'm going to do 1.3 minus 1, and that's going to give me 0.3. Make sure that you're doing this in the calculator, because sometimes we're a little bit confident and we miss a couple zeros or add a couple zeros where they're not supposed to go. So make sure you're checking this in the calculator. So now I know that my r was 0.3, but if you remember, the r is always given to us as a percent. So now we have to take this percent and we have to convert it. Sorry, we have to take this decimal and we have to convert it into a percent. If you go back to the previous lessons, remember I told you to go from a decimal to a percent, you're gonna divide, sorry, to go from a percent to a decimal in the previous lessons, to go from a percent to a decimal, we're gonna divide by 100. But to go from a decimal, which is what we have, to a percent, you'll do the opposite. And if you remember, the opposite of division is just simply multiplication. So we're going to multiply by 100 to get our percent here. So I already know that my r is 0.3. My r is equal to 0.3, but I'm going to multiply that by 100, which gives me 30%. So for here, I have a 30% growth. That's my answer for C. Again, all I had to do was subtract what's inside of the parentheses minus 1. Whatever decimal I get, I'm going to convert it to a percent by multiplying by 100, and that's going to give me the percent growth or the percent decay. So now, let's look at another example. In this example, we have y equals 55 times 0.98 to the t. And again, they're asking me, is this an exponential growth or decay? If I look at my notes here on the side, I see that if inside of my parentheses I have something that is smaller than 1, then that means that I have an exponential decay. So since 0.98 is smaller than 1, this is exponential decay. Okay? Now my initial value, once again, if I have y equals 55, 0.98 to the t, my initial value is just simply whatever comes before the parentheses. So my initial value here is just simply 55. And now the question is this the rate of growth? What is the rate of growth or decay? In this case, let's see what we can do. So we have y equals 0.98, sorry, not that. We have 55, parentheses 0.98 to the t. So again, I'm going to do the same thing I did before. I'm looking, this is a decay, so I'm looking for something that when I take it away from 1, since it's exponential decay, it has to give me 0.98. I'm trying to figure out what do I take away from 1 to give me 0.98. So I'm going to do 0.98 minus 1, and that's gonna give me negative 0.02. And it's going to give me a negative number because I already know it's an exponential decay. So we're going to ignore that negative. That's just, it's giving me, once I get that negative, I know that that means that I'm doing an exponential decay. So if I do 1 minus 0.02, I know that that's going to give me 0.98. So to turn that into a percent, because we need a percent, I'm going to do 0.02 times 100, which gives me 2% decay. And that's my answer. Okay, so all you have to do to go through these steps is figure out, do you have something bigger or smaller than 1? If it's bigger, it's growth. If it's smaller, then inside of your parentheses, then that means it's decay. Your initial value is always the amount before the parentheses. And to figure out your rate of growth or decay, you're going to take whatever's inside of your parentheses, subtract it, do that minus 1, and whatever you get, you're going to multiply it by 100 to get your percent of growth or decay. You can go over these examples once again. Just rewind the video and make sure you take your time going through these examples so that you know that what you're doing throughout your task.